What's up everyone, RyFX here. Today I'm going to teach you how to build a computer. I'm going to go into steps of what each component does and what you need in the computer into actually building the computer itself. When it comes to a computer budget, it could go anywhere from possibly free to into the thousands to 10,000s or whatever. It just depends on what you buy. In my opinion, the first thing you should start off with is your processor. The thing about the processor is that usually going by what price that is, it's pretty much going to tell you what the price of your other components are going to be. It's usually by half, I would say, is what the rest of your components are, what price range your other components are going to be at. Besides your graphics card, if you decide to get one. So with the processor, this is basically telling you the speed of your computer. It's gonna make your video rendering or games load faster, save faster. Everything's just gonna process and work a lot faster. If anything that I should compare this to as far as a body part, this is basically the heart. It's gonna like push everything, all the power, like through the body of the computer essentially. So this is an essential part of the computer. So I highly recommend you start off at this point. Usually with the processor, you have this little chip. It's very tiny. It's probably the smallest part of your computer and the most expensive part as well. And it's just a chip and some pins on it, and it usually comes with the fan. In this build, I'm using a Intel Core i5 processor, 4690K. So yeah, if you have an AMD processor, or if you're deciding to use that, it should be essentially the same thing, the way you put it together and everything. The next component of the computer, and the largest as well, is the motherboard. This is essentially the nervous system or the skeleton of the computer. This is going to hold all the components from the processor that I showed you into all the other components that I'm going to go into after this. So from your USBs to your PCI to your graphics card to your RAM, all your fan connectors, your power connectors, everything's going to go into this. This is another essential part of the computer that you will always need. In terms of pricing, this is usually going to be half the price of your processor, if not almost the same price as your processor. In this build, I'm using an MSI Gaming 7 motherboard, and this was roughly around $50 less than my processor. My processor was $200 and this was $150. And when it comes to matching components, the best way to do it is off what the motherboard says. In this motherboard, it uses a 1150 processor socket type. So when you search this up on Newegg or wherever you decide to go to search for your components to buy, usually go off what the motherboard's saying pretty much after this. So if it says it supports a certain socket type like 1150, you can only use 1150 processors with this. Like this one says I could go up to a 2400 megahertz DDR3 memory, so I could use that kind of memory RAM in my motherboard here. And then it also supports PCI 3.0, so I could pop in a PCI 3.0 graphics card in there, and it has several PCI times 1 slots, so I could pop in PCI times 1 slots 2.0 as well, and it has USB 3.0 in it. So this is basically just going to tell you what is compatible with everything. So go based off of what motherboard you decide to go with. As far as buying your other components, it'll make it a little bit easier. The next component is the RAM, which means random access memory. This is essentially a short-term memory. It's kind of like part of the brain, but it's just kind of like a short-term type thing. When you have your application, say, I don't know, your browser, like Google Chrome, or your editing software, or whatever, each of those take a certain amount of memory, and if you have more tabs open or something like that in, say, your browser, each of those tabs are going to take a bit of memory. It's essentially kind of like holding on to and trying to remember to stay open and essentially stay where it's at. If not, if it wasn't for this, essentially everything would be closing down and shutting down constantly. If you're going to use a lot of applications all at once, I highly recommend you check your motherboard on the maximum amount of memory you could put. So if you're using, say if your motherboard says you could use up to 16 gigabytes of memory, I highly recommend you buy 4 gig sticks if you have 4 slots, so you could take advantage later on if you ever need more memory in your computer. But if your motherboard can handle 32 gigabytes of memory and you have only 4 slots, so you would have to use 8 gigabyte sticks for that. And I highly recommend you buy 2 sticks at a time. There's a certain mode on your motherboard. If you have 1 stick, it'll go into single channel mode, which it kind of clogs up. You could tell your computer kind of gets a little bit sluggish, having all this stuff processing and dealing with all the operations of the system. So I highly recommend you buy 2 sticks at a time. You'll see a different performance in your computer since you have 2 sticks essentially working together. And then once you have 4 sticks, it'll be a significant difference in terms of speed of your computer. The next thing I recommend is a hard drive meant for just to install your programs and your operating system. The reason for this is because your operating system and your programs take up a lot of resources, pulling out and writing and reading certain pieces of data. So I highly recommend you have a separate drive just meant for your applications and stuff, not for your pictures, not for your video, not for or saving video. You will see a significant speed boost if you have it separated. What I'm using in this build is a Samsung SSD 850. It uses less power, it's small, and it essentially lasts a lot longer. and it's a whole lot faster than a regular hard drive. So I know this is going to be a little bit confusing, but when you're opening a program, essentially it has to read from where that program saved on your hard drive, and has to read that. So once it's going through your your motherboard to your processor and all that stuff, sometimes your hard drive can essentially affect the speed of the program opening up. So if you're using a regular hard drive, plated hard drive, which I'll have one as just a storage device after this, it'll be pretty slow. But if you have something like this, everything's gonna be pretty much instant. It's just essentially the use of the SSD, and why I highly recommend using a SSD for your operating system. So if you decide to do what I was saying and having two separate drives, one for operating system and applications and then one for storage, well, in this one I'm going to be using just flat out storage. For this, you could use pretty much any drive. A real slow one, it doesn't really matter. This is just going to be used for storage, saving your videos. Make sure everything's safe just in case something goes wrong with your operating system and you have to reformat or whatever. This will keep everything a lot more safe. So it doesn't really matter in terms of speed. I'm using a 4 terabyte Western Digital green drive in this computer. It only runs at 5400 RPMs. In reality, it doesn't really matter because this is just being used as a storage device. The only reason higher RPM drives like 7200, 10,000, or any of that is if you're using it as the operating system and storage device, all in one, as I was explaining earlier. So when it comes to having these two split up, it doesn't really matter what RPM you use for your second drive, unless you just want those videos to pop up, or music or whatever you have saved on there to pop up, a lot more instantly. The next thing you'll need is a power supply. This is essentially going to power each and every component separately, and provide the proper voltage and wattage to each component, so nothing explodes or anything like that. There is power supply calculators. You could just Google search it, and you could put in all your computer components, and it will give you an estimator of how many watts you're going to be using in that computer. Just make sure you realize that is an estimator. So certain components can go a lot higher than what that is estimating. So say if mine for example is saying that it would be about 480 watts after using all the components that I'm using. But the thing is that if I ever want to overclock, which is going into something else, or if it's going at 100% load in my CPU wattage as well as my graphics card and stuff, you want a little bit more headroom, because if your power supply um, can't handle, uh, or is just barely enough to push all the wattage to those components, your computer could turn off while you're doing something important. So the best thing to do is to have an extra, to have some more headroom when dealing with wattage. So since mine is around 480, I believe that's what I said. It's best off I have at least 100 to maybe 200 watts extra, just in case, just for some headroom and leeway, because that is an estimator, and it could possibly be a lot higher than that. And then if I want to add more components in the computer, and if I want to overclock it or whatever, it'll give me some headroom, so then I won't have to buy something in the future as well. So I'm using a 700 watt power supply in this build. So I highly recommend you go at least 200 watts over what it's actually estimating. It's usually a good idea. And if you're adding, say, extra graphics cards, you have to take into account those graphics cards are very power hungry, and they could pretty much eat up your entire power supply off of just one graphics card. Take that into account. In this build, I'll be using a Kingwin Mach 1 700 watt power supply. And then the next thing you want to get is a case. There's all kinds of cases. There's mini ATX, there's ATX, there's BTX, I believe. There's all kinds of cases out there, from small to tiny to kind of small to large to just flat out huge. So this is another thing where your motherboard will tell you what kind of motherboard it is. Like mine's an ATX, and this case says it could take ATX boards. So really, that's all you have to really pay attention for, as well as what space you're putting in. All these cases come in different dimensions and things, so pay attention to the dimensions of it, so you don't have your case, out of place. And in this build, I'm using a NZXT H440 case. Now next is the graphics card. This could be an optional piece, or this could be a required piece. It depends on what CPU you get. If your CPU has integrated graphics on it, you won't have to get this graphics card at all. But if it doesn't have integrated graphics, then you'll have to purchase a graphics card. You would have to check your CPU if it has integrated graphics on it. The CPU I have has integrated graphics. I was using it for a little bit until later on I decided to put a graphics card in there. The purpose of having a separated graphics card in there is that it has its own CPU. Well, actually, it's called a GPU in it. So it's going to separate its own processes for anything video or anything game related. For games, this is a really good thing you should invest in, because it will render everything in higher textures. You could put everything in a higher mode, and everything will look a lot better. And also, graphics cards are good for having multi-monitors. So if you want to have a bunch of monitors on your desk, the best thing to do is to have a graphics card. with the CPU, there's some with the integrated graphics on it, and they could support up to 2 monitors. But with the graphics card, you could have up to 3, 4, maybe 6. I think there's one that could do 9 by itself, which is crazy. But yeah, this is gonna render the textures on your game a lot better. In certain situations, it could render your video faster if you're doing editing and all that stuff. So it's a good thing to have a graphics card. But if you have integrated graphics, you could just work off that for a while until you feel you're ready to have a graphics card in your system. So this is something that can be done later if you have integrated graphics already in your computer. But if it's a required option, then of course you have to get a graphics card right away, or else you won't be able to see anything on your computer. So now here comes pretty much the easiest part of the whole thing, is building it. The first thing you want to take into account is, I highly suggest you wear some shoes or some pants. Make sure you're kind of away from the carpet as much as possible, because these devices are sensitive to static and all that stuff. You could damage your device with enough static. So be aware of that. So the first thing you want to do is go to your socket area, pull the lever open and open that area, and there's going to be a little arrow on your socket, on your processor, as well as that socket area, and you want to line up those arrows so so the pins are on the processor are lined up properly. If you do not line up those arrows correctly, you could damage the processor as well as the motherboard socket. And then after you put that in there and line it up correctly, you just close the lever down. And the next thing you want to do is take your fan that you got with your processor, or whatever heatsink or whatever you want to use for your processor, and place it on your processor. It'd be pretty simple. You just twist it and it should lock down into your motherboard, and you want to take the fan connector and connect it to the nearest fan 3-pin or 4-pin port on the motherboard so it could power the fan. There are maybe if you're using a different heat sink or fan for this, make sure you have some thermal grease on there. If you're using the fan that came with the processor, it most likely has thermal grease on it already, so you probably shouldn't need to worry about it. Next thing you want to do is place in your memory, whether you have 1, 2, or even 4, or however many that your motherboard can handle. That's the next thing you want to place in to your motherboard. All you have to do is pull the sides of it open, and then you just push your memory in there, and they should close onto it and latch on. Now the next thing you want to do is open up your case, and make sure that there's some little posts in the case. They should be maybe 1/4 of an inch tall. They're pretty tiny, but this prevents the motherboard from completely touching the back of the case. You want to have it heightened, so make sure that's on in the case, or there's probably a bag that's given to you in the case that you could just place the post yourself. But most new cases, they already have it placed in there for you. Then once you have those posts, you want to place your motherboard in the case and make sure they're lined up. And then you want to take whatever screws that is given to you, meant to screw in the motherboard into those posts, and screw them in. Next thing you want to do is place in your hard drives as well as your power supply in your case. And of course screw them using the available screws that's either given to you from the power supply or the case, as well as the hard drives. Next, you need to take your power supply cables and route them to whatever device they need to connect to. And first I'm connecting it to the hard drive back there. And then now I'm placing the 24-pin connector into the motherboard, which is usually somewhere near your RAM. And then next you want to connect the 6-pin 12-volt CPU connector into the motherboard. Now I'm placing my SATA hard drive connector. Should be a small, like L-shaped innard connector, which connects your hard drives, your DVD players, or anything like that. So it should connect from your hard drive or whatever device into your motherboard. Now I'm connecting my operating system or program SSD drive, connecting the SATA power as well as the SATA connector. Next I'm going to connect the power button connectors or activity connectors. Essentially this is going to be, you're going to have these within your case already connected most likely, and essentially what some of them are going to do is it's going to tell your power button to send the signal into the motherboard, so your motherboard and computer turn on. So this is what this is going to do, as well as provide activity lights, just to say when something's working or maybe it's not working, and it's also going to tell the computer to power off if you press the power button as well, or even reset button, whatever your case has. This is essentially what these little cables are going to do. So you have to look at, it's usually at the very bottom right side of your motherboard. You might want to check your manual. All motherboards are pretty much different on what they have or where it's located. It's very tiny pins, so look into where they're at and which pin it goes into. They're very tiny and small. I really had trouble capturing it on camera because it's so tiny. So I suggest you refer to your manual on where to connect each device. The connector itself should say, as far as the part in the case, the connector from the case goes, it should tell you where the name of each connector. Now next you want to, if you have any, drop in your PCI devices, or if you have a graphics card, you could drop that in as well to your PCI Express 3.0 times 16 or 32 or whatever you have in there. And if the device is PCI X1, you can use it in the PCI times 16 or 32. It will those 16 and 32 and times 4, they're all backwards compatible, meaning they could go a step behind. I'm not saying that an X4 or an X1 could fit a times 16, or times 32. That's not going to work. It's basically going to work with whatever's below it. So an X4 can work with the X1, but an X1's not going to work with an X4 because that one's higher than it, so it's not going to work. So you could drop in a times 1 into a times 16 slot if you wanted to. And now comes the moment of truth of connecting your computer power and all your keyboard to your USB port or your PS2 port. Some keyboards and mouses still use PS2 ports. That's what they're called. Connect everything together. So now comes the moment of truth. Turning your computer on. From what you see, it turns on fine. And once you turn it on, I highly recommend you go to your BIOS first. Usually when your computer turns on, it will say press this or that in order to go to your BIOS. It usually pops up within like 5 seconds of your computer turning on. So you kind of want to catch it before it goes into something else. So for mine, it says press delete in order to go into the BIOS. So now I'm in the BIOS, and from here on, all BIOS are different. It depends on what kind of motherboard you have. They all have their different setups and everything. So what you want to do from here, I really can't show you because they're all different, is that go into your settings. There should be somewhere in your BIOS, there should be an area where you could set up your boot devices. Sometimes it's set up to pull off your hard drive immediately. Well, since this is a new computer, you're gonna have to run off either a USB device or a CD device to pull off your operating system from there. So you have to set up your boot order in order to pull off your operating system, so you could put the operating system on your hard drive. So set up your boot device to either pull it from the USB that the operating system's on, or maybe it's on a DVD or CD. So you want to make sure you set the boot device to that device. So like I don't have a DVD ROM drive in my computer. So for me, I would have to use a USB DVD ROM drive in order to get Windows onto this computer. So you just have to connect the USB CD or DVD ROM device into the computer, and it should show up in your BIOS that you could use CD or DVD USB device. And just set that to the first boot order. So, and then once you do that, save your settings in the BIOS, and put in the operating system. And once the computer resets, or the BIOS has it restart or whatever, it will automatically boot from or say to boot from that device. So once it does that, you should be loading Windows onto your computer. And once that happens, it's pretty much all up to you from there. You just have to load Windows up, and you should have a full functioning computer. So that's the end of this tutorial. I hope that helped you out in building your new awesome computer. I hope you found this helpful, and thank you all for watching, and I will catch y'all next time. Bye-bye.
If you enjoyed that video, please be sure to like, comment, share, and subscribe. You have 5 seconds to comply. 4, 3, 2, 1.